I'm going to give some highlight of what I learned during this semester. So as me living in kind of place, a lot of earthquake, we know that earthquake is actually happening like in some minutes or some second. And then from the earthquake, I know that it is the wave and then it feels shaking. But after this class, I understand that actually that shaking, the earthquake, is actually can map the earth situation inside. So for example, in some specific place, they have some shadow zone, mean they didn't detect any earthquake at all. So it's kind of interesting. But they have some surface wave, but P wave and S wave, they didn't detect it. So imagine that situation is also happening when you living in Earth. We can map the inside of the liquid core, and because we detect the shadow zone, and then we can implement that situation into the planet A, another planet. And then if we detect big shadow zone, mean maybe the inside liquid core is also bigger. So for example, in our data collection, we using some kind of data from Peru, 2019 earthquake. And then we note that actually if the station recording the station, if the station recording the earthquake located more than 103 degree from the earthquake source, the earthquake is not detected P wave and S wave. So shadow zone is detected here in this data collection. So we are stacking several stations together. And then using the simple calculation, we can note using some the easy calculation, we can know that actually the Earth liquid core radius is around 3,970 kilometers from the um, calculation. But if we see the fact that the radius of the liquid core is actually around 3,000 kilometers, so it's almost similar. Using this data also, we can know the location of the core mantle boundaries, how many kilometers deep below our pit. So it's kind of interesting, right?